Hello everybody, I'm back. It's Mr. McAllen, and I'm going to show you one other example of some problems that you're going to have to do in the homework. And what it has to do with is they're kind of vague about what you're going to have to actually do with this linearization. They're going to ask you to approximate certain function values. They're not going to tell you the function. They're not going to tell you the point of approximation. They expect you to figure out these things based on what they give you in the problem statement. So this is an example of the type of problem they're going to give you, and they're expecting you to make a linearization on your own without too much hand-holding, if you will, or leading you along and telling you exactly what to do. So here's what they're trying to get you to do. This first example says approximate the square root of 8 using a linear approximation. What should the function be that you use to do this linearization? Where should it be centered at? And then they want you to find the linearization equation. So let's draw a picture of what's really going on here. We have a function that's the square root. It looks something like that. Square root of x. They want us to find out what the square root of 8 is. So here's the thing. This is where 8 is, and if we go up to the function, it's got a value of the square root of 8. Now I know if you simplify it, it's 2 root 2, which would be about, 2 root 2 is simplified root 8, which I know root 2 is 1.414 because I'm a crazy math teacher. So 2 times 1.414 would be 1.414 times 2 would be 2.428. So 2.828. So I should get 2.828 as my exact value, but I'm not trying to get an exact value. I'm trying to find a linearization. So here's the thing. If I do my approximation at 0, do you see how the linear approximation is not going to be anywhere near, like this will be L at 8 if I centered it at 0. If I center it at 1, do you see how the linearization is going to be way off? There is an appropriate value to center this approximation at. And the appropriate value would be the nearest value to the perfect square root that you could use that's closest to 8. So I hope you're thinking right now that it's the square root of 9, or maybe the best value would be a equals 9. If you choose at 9, do you see how the tangent line is almost exactly crossing over what the square root of 8 value would be? Now there is going to be a difference in the line's value and the curve's value, but it's going to be pretty close. Let's see how close it gets. So we start out with a linearization equation. L of x equals, remember we had f of a plus the derivative at a times x minus a. Now you should know what the a value is. Where it should be centered at is the x equals a value. Let me erase this. I'll erase that so that we can kind of focus on this linearization equation, L of x. So f of x is the square root of x. F of a, well, a is equal to 9, so f of 9 is equal to the square root of 9, which is equal to 3. F prime of a is 1 over 2 root x. Now that's only because we've done these shortcuts 100 times, and you know what the derivative of the square root of x is. So then f prime at 9 is equal to 1 over 2 root 9, which would be 1 over 6. Now, we know we can now put together our linearization equation. L of x is equal to f of 9, which is 3, plus f prime of a, which is 1 over 6, times x minus 9. Now you might be like, oh, well, that doesn't look like it's going to be anywhere near 2.828. But We want a linearization at 8. So I'm going to plug 8 into this equation. 3 plus 1/6, 8 minus 9. Looks like the pen isn't working too well. So now that's L of 8 equals 3 plus, now this is going to make a value of negative 1/6. I don't know about you, but 1/6 I think is 0.1667, because 1/3 is 0.333. So it's 3 minus 0.1667. So I think that would, okay, so let's do the subtraction. 0.1667. So here we have 2. We're going to carry and carry again. So this will be, then we've got 3, and this is 3, and this is going to be 3, and this is going to be 8, 2.8333 repeating. God, I hope that's right. That'd be really embarrassing if I just subtracted wrong in front of everybody. But, okay, so the linearization at 8 is equal to 2.833. That is a bit under what it should be, 2.828. The only reason why I knew 2.828 is because I've done enough work with square root of 2 to know it's like 1.414. So let's see if it should be under. So the actual value is 2.828, and do you notice how the blue line of tangency is a bit above, which might be why it's 2.833. Let's check it with Desmos, and then we will have a pretty good understanding of what we're supposed to do on these types of problems that we see in our textbook. Here we go. Let's go to Desmos, and I'm at the camera, so here, let me just, let's go to Desmos, and I don't want to see that. That's the last video I just did. So this is going to be the square root of x. That's the old linearization. So let's try from the last video. Let's look at what was the equation. It was, let me go back and look. I just forgot the linearization. It's 3 plus 1/6 of x minus 9. So 3 plus 1/6 of x minus 9. And you can see here that at, I want to find out what the square root of 8 was. So you see here how like the two functions look almost identical. Like they're like right on top of each other. You can't even tell the difference. They're graphically the same, but they're not the same. I don't want people to say like, hey, you're saying they're the same, but they're not. So let's use a table to see what the values really are. If I put 8 in here, oh, look at that. My subtraction was not too bad. 3.833. And look at what the function value is, 2.828. Now I know you're going to say 4271, but I don't remember like all the decimal places or square root of 2. I've got a life, so anyway, hopefully this makes sense as far as what you're supposed to do on these types of problems. They give you a function to evaluate. You need to pick the point to center the approximation, and once you pick that point, that's your a value. You need to pick the proper function to do the approximating with. If it's a square root of 99, then you're going to use a square root function. If it's any other type of operation with a function, try to think about what that function might be to do that type of operation. So they're leaving it a bit open-ended to make you think about it. And I look forward to hearing your comments about what you think of this process. Remember, using an equation of a line to model something complicated is much, much easier than trying to actually figure out what the square root of 8 would have been if you had to do guess and check. I don't want to go over this too much longer and take too much of your time up, so I hope this helped you understand the concepts, and please try the problems in the book, and I look forward to hearing comments.